Okay, so chapter 6 is all about polygons and quadrilaterals. So first we gotta learn about what a polygon is. Polygon just means many-sided figure, okay? So first we're gonna talk about some vocabulary words that go with polygons, many-sided figures, okay? Equilateral, just meaning equal sides, okay? Equiangular, equal angles, okay? So these arc marks show equal angles, these dash marks show equal sides. And since this shape has equal angles and equal sides, it is a regular polygon. We call it regular. It's actually a hexagon because it has 6 sides, okay? We only call something regular if it is both equilateral and equiangular. This brings us to our polygon angle sum theorem. The way that this works is the sum of the measures of the interior angles of any n-gon. So you can think of hexagon, pentagon, dodecagon, nonagon, all of those things. We can find the sum of the measures of the angles by doing the number of sides. And we can even go past that. We could just say 15 gon, 20 gon, 432 gon. It doesn't really matter what number goes right there, but that's the number of sides. And we have this formula, n minus 2 times 180 equals the sum. So for our hexagon right here, we could do 6 minus 2 times 180. So 6 minus 2 is 4, times 180 is 720. Okay, so the sum of all the angles in a hexagon is 720 degrees. So then going from there, I have a little note down here that says to find each interior angle of a regular polygon, divide the sum by n. So I know that 720 is the sum of all the angles. If it's a regular polygon, I know all the angles are the same measure, and there's 6 angles. So I can divide 720 by the number of sides, 6, to get that each angle would be 120 degrees. Okay, so that tells us how we can get each angle. Each one of these would be 120 degrees. So that's a very important part of the polygon angle sum theorem, is dividing by the number of sides to get what each angle is. So this is each angle in a regular polygon. Actually, and this specifically is a regular hexagon. Okay? Then I want to talk about the polygon exterior angle sum theorem. Okay? The sum of the measures of the exterior angles of a polygon is always 360. No matter how many sides you have, it is always 360s. Always means always. Okay? There's not like sometimes it's not 360. No, it's always 360. So in a hexagon, it's 360. In a pentagon, the sum of the exterior angles, 360. In a quadrilateral, so squares, rectangles, kites, all of those, 360. The exterior angles of a triangle, also 360. It's always going to be 360. The sum of these exterior angles. Remember, for an angle to be counted as exterior, it has to extend one side and share a wall with a side of the shape, okay? That's a very important part of that right here. So if I added up all 5 of these angles on this pentagon, it would equal 360. Now, if this is a regular pentagon, I can take 360 and divide by the number of angles because they're all going to be equal, right? Because all the interior angles are equal. So if I wanted to know what the measure of each exterior angle is of my hexagon up here, okay, I would take 360, because it's always going to be 360. The 720 doesn't even matter. 360 divided by the number of sides, there's 6 sides, okay? So then I get each exterior angle is 60 degrees. Now I'm going to show you guys why this makes sense. So I'm going to draw this out again. It's going to be much worse than I drew it the first time. Now, if I extend one of these sides right here, okay, this is my interior angle, this is my exterior angle, right? We found, if this is a regular hexagon that I drew, we found each interior angle is going to be 120 degrees if it's regular, and each exterior angle is going to be 60 degrees if it's regular, which I'm assuming here. Now, right here, this is a straight line. We know they're supplementary. They equal 180. 120 plus 60 equals 180. So this makes sense. That's another way of finding exterior angles, is just by subtracting from 180 to get what each interior angle is. So that's something to think about as well. So there's a lot to this. Polygons, remember, they're many-sided figures. The poster that I have up in my classroom, but it's also on the posters page in modules. So if you go to modules, topic 6, there's a posters page, and it has all my posters. I have a great poster about this that is very helpful to you. So look that up, and that's what 6-1 Polygons is all about.